All right, Mr. Dell here, looking at this is a review preview from CC2 Section 3.2.4, number 3-74 is what I'm going to take a peek at today. All right, so we are looking at calculating the products of decimal values, right? So our rational numbers here in decimal notation, calculating those products. So using the rule for decimal multiplication. So I'm going to rewrite these so we can see them better. So A is negative 0.04, and we would say that's 4/100ths, negative 4/100ths, and this is negative 0.1, which is negative 1/10. So if we're reading it, it's 4/100ths times 1/10, right? So what we're needing to do is when we do the mental math here, multiplying of decimals mentally, we only consider the digits, right, as a number without decimals. So in other words, if I were to rewrite these numbers without decimals, it would be, I would write this 004, no decimal, which any zeros in front of a number just really is just that number. So really it's 4. And if I wrote this number without decimals, I'm going to say it's 01, which is just, in this case, 1. So what is 4 times 1? 4 times 1 is 4, right? So the first process of multiplying decimal values is just consider the digits and write the digits without decimal and determine what number you're dealing with, what integer you're dealing with, and then multiply your integers, right? As well, too, we need to consider signs. And remember, when we're multiplying here, a negative times a negative, anytime you have a negative number, whatever that number is, and another negative number, and you're multiplying negatives, you always end up with a positive, right? So we know our answer is going to be positive already by knowing this rule of multiplying two negative numbers. Okay, so I have 4. Now, let's go back to what do I do with this decimal concept? Well, after I've done my multiplying and get my integer, I then need to go back and count how many values were there in the decimal place, right? I have one digit, or how many digits, I should say, not values. How many digits? I have 1 digit, 2 digit, 3 digits. I have 3 digits in the decimal place, so therefore I need to move my decimal place to the left 3 times. So I start the decimal place at the end of my integer, and then I move it 1, 2, 3, right? I notice I'm moving it, even though there's nothing there, that nothing becomes zeros, right? We move it and we put in values of 0, and then this is where the decimal ends up. So my answer is going to be a 0.0, right? I always put a 0 in front of my decimal value. And then I have 0.004, which represents 4/1000ths. And that should make sense, because if when I read this, right, I read this problem, I told you this was 4/100ths, and I told you this was 1/10. When you read decimal values, 4/100ths and 1/10, and when you multiply that, what's going to happen in the denominators? 100 times 10 is 1,000. So this, as a fractional value, is 4/1000ths, and that's what I just wrote. So multiplying decimals, that's the process or algorithm of multiplying decimals, okay, mentally. So let's look at B then. B, I did A, and I spent a little more time there. So B, we'll do a little quicker. We have, oops, let me rewrite that. I did too many zeros. So I have 3/100ths times, and it's a positive 3/100ths times a negative 2/100ths, right? 3/100ths times a negative 2/100ths. So first of all, I have a positive times a negative. And remember, a positive, in this case, positive times a negative is a negative. Okay, opposite signs, when you're multiplying opposite signs or dividing opposite signs, you end up with a negative value. So in this case, I know my answer is going to be negative, but I'm going to ignore the decimals and consider just the digits. And here we have 003, so really it's just 3, and 002, which is just 2. So 2 times 3 is 6. Now I consider the decimal places, right? So I know my decimal starts here at the very back of any integer. So I go back and I look, okay, I've got 1, 2, 3, 4 digits in the decimal places after the decimal place. So 1, 2, 3, 4. So I take this and I move it 1, 2, 3, 4. Move it 4 times. How many spaces did I create? I created 3. So when I do, I put in those 3 zeros, and that's where the decimal place ends. And I always add a 0 also in the very beginning to just shield where that decimal is. So my final answer in this case would be negative. Remember, we already decided that negative 0.0006 or 6/10,000ths, right? 6/10,000ths is the answer for this problem. Okay, there's B. C, so let's consider C. C is 7/10 times 4/10. Once again, a tenth times a tenth is going to be 100th. I mean, that's also something we can think about. A tenth, just by reading it, hopefully that you hear that. A tenth, this is 7/10 and 4/10, but anytime you have a tenth times a tenth, you're going to get 100th, right? So I know I'm looking at just my 7 times my 4 when I'm looking at just the integer values without decimals, and that is 28. And then I'm considering how many digits behind the decimal are 1, 2 digits. So I take my decimal here that's at the end of that integer and I move it twice. So it's going to end up in front of the 2, and then I make sure I add a decimal there. I've got positives, so it's going to be positive 0.28 or 28 hundredths. Okay, so that's my answer for C. Okay, now let's look at D. D gets a little bit more lengthy as far as what it's asking us. So let's look at this together. So D, you can read that. D says, Stacy said, Stephanie looked at my answer, the last problem, which we did, the 7/10 times 4/10 equals 28 hundredths. Usually when I multiply, I get a bigger answer than the numbers I start with. 28 hundredths is less than 4/10 and 7/10. I must have made a mistake. So Stacy's saying, normally when I'm doing multiplication, I'm getting bigger numbers, right? Which makes sense when you're multiplying integers. If I'm saying 2 times 3, I get 6, right? If I'm multiplying integer values or whole number values, I'm going to get a larger number when I'm multiplying because I'm getting bigger. But in this case, that's not the case. So then Stephanie responded and said, well, 1/2 times 1/2 is 1/4. And 1/4 is less than 1/2. She said, I think when you multiply by a fraction or decimal, less than 1, that's the key thing, less than 1, you get less than what you started with. And is she true? So the question says, write a sentence or two about who you think is correct and why. So is Stacy correct or is Stephanie correct? I mean, Stacy's right. When you do multiply integer values, you do get a larger number. But Stephanie's right because she's talking about when you multiply by something less than 1, then you do end up with something smaller than what you started with, right? I mean, I could give you an example, 1/2 times 6. 1/2 times 6 is 3, right? Because I'm taking a fraction of the whole number. So in this case, I'm taking 7/10 times 4/10. I'm taking a fraction of a fraction. So taking a fraction of a fraction is going to create a smaller fraction. In this case, the 28/100ths, right? A fraction of a fraction. A fraction of a whole number makes it a smaller than a whole number. A fraction of a fraction is going to just even make it even a smaller of a fractional value. So the key word is, and I'm going to let you word it. I'm not going to write your sentences for you in this case. So I want you to write a sentence or two about who's correct. So I'll at least tell you Stephanie's correct. Why? Because anytime multiplying by less than a number by a value less than 1, it makes that value smaller than itself. Anytime multiplying by a value less than 1, between 0 and 1, really, I shouldn't say less than 1 because then we get the negatives and that's a whole nother conversation, but a positive value between 0 and 1. So I'll say a value between 0 and 1. Anytime multiplying a value between 0 and 1, you're going to get less than the value that you're multiplying it by, right? Okay, so I'll let you word that in a sentence, but there's the response. All right.